So here we want to square root x to the fifth. We want to simplify that. We have the square root of x to the fifth. How do we square root something with a variable? Well, if you want to square root anything with a power as a radicand, if this power is even, we can easily square root it because we just need to divide the power by 2. So x to the fifth can be broken down into x to the fourth times x. And the reason I do that is because I know I can square root x to the fourth. Okay, so if we separate the square roots, that's the square root of x to the fourth times the square root of x. The square root of x we have to leave as it is. But the square root of x to the fourth, we simply, when we're square rooting, we simply divide the exponent by 2. So the square root of x to the fourth is x squared. And so we have x squared times the square root of x. Let's do another example. Suppose we want to simplify the square root of 8y squared. Well, I know I can square root y squared. The square root of y squared is just y. If I divide 2 by 2 gives 1. But 8, we have to break that up. And as we've seen, 8 can be broken up into 4 times 2. So we'll have 4 times 2 times y squared. And now we square root things we can square root. We can square root 4, that's going to give me 2. We can square root y squared, that's going to give me y. And as you do this, you may want to cross them out so that you're keeping track of everything. What are we left with? The square root of 2. So we write that back as the square root of 2. So the square root of 8y squared can be simplified to be 2y times the square root of 2. Let's take some more examples when you can have cube roots and you can simplify cube roots. So here we want to take the cube root of 48. We want to simplify that cube root. And now we have to look for perfect cube factors. Before, when we were doing square roots, we looked for perfect square factors of the number. Now we're looking for perfect cubes. So I'm thinking, well, 48 is 16 times 3. That's not a perfect cube. But 8 times 6. 8 is a perfect cube because 2 cubed is 8. So I can break this down into the cube root of 8 times 6. And we can, just as we did with square roots, we can break this up into separate cube roots. The cube root of 8 times the cube root of 6. And I know the cube root of 8 is 2. So this becomes 2 times the cube root of 6. And you have to be careful now as you're writing all these numbers. The cube root, the little 3 here has to be small. That sits the index in front of the root. Has to be small so we know it's the index. So this cube root of 48 is 2 times the cube root of 6. Now we can also do this with variables. Suppose I want to simplify the cube root of 54 times y to the fourth. Now again, we have to break down the number into a perfect cube times something else, if it's not already, which it isn't. And also the variable. Now the variable, the power in the variable now has to be divisible by 3. So we want to break down this power to a power divisible by 3. So what we can look at is 54 is 27 times 2, and 27 is a perfect cube. So we'll write 54 as 27 times 2, and y to the fourth can be broken down into y cubed times y. Y cubed times y. And why do I do this? Because you can cube root y cubed easily. It's just going to be y. If it's divisible, if the exponent's divisible by 3, we can cube root it. So now let's simplify this. The cube root of 27 is 3. So we'll write a 3. I'm going to scratch this out. The cube root of 2 we can't do, but the cube root of y cubed I can do. Cube root of y cubed is y. So these go. And what am I left with? Underneath the radicand, I have 2 and y. So we have 3y times the cube root of 2y. So the cube root of 54y to the fourth power is the same as, or the simplified version is, 3y times the cube root of 2y. Now why do we want to do this? This technique is useful if we're adding and subtracting radicals. Here's a neat application of cube roots and square roots and radicals in general. There's a show on TV, or was on TV, and they make movies called Star Trek. And there was a particular series called Star Trek The Next Generation. And one of the enemies of humankind on that show was some beings or robots called the Borg. And they have a ship in the shape of a cube. And they go around assimilating and kind of eating everything, in a sense, in space. But regardless, their ship is the shape of a cube. Now, this is a TV show, so they use a model to make this ship for the show, for the camera. And this model, let's say, suppose the model of this ship has a surface area of 121 square inches. So the surface area is 121 square inches. We want to know what are the dimensions of this cube, what are the length, width, and height, which in the case of a cube will be the same. So what we do know is that the surface area is 121 square inches. However, the surface area of a cube, you have to think, here's a cube. We are seeing 3 sides, but there are 3 more sides to this cube. The cube has 6 sides. Each side has, I put the dimensions as x times x times x, because they're going to be the same for a cube. So the area of one face of this cube is going to be x times x, which is x squared. That's the area of one side of the cube. So the total surface area will be 6x squared, sorry. So that's the surface area of the ship, 6x squared. And we're given that surface area, total surface area, is 121 square inches. So we have this equation, 6x squared equals 121. How do I solve this for x? Well, we could divide both sides by 6. So divide both sides by 6, we get x squared is 121 over 6. Now I want to figure out what x is. What is the dimensions of this cube? Well, in order to get x, I have to, what we call, square root both sides. And the square root of x squared is going to give me x. And on the right side, we have the square root of 121 over 6. Now I can write this separately as the square root of 121 over the square root of 6. And the square root of 121, we know what that is. That is 11. 11 times 11 is 121. And the square root of 6, well, we're going to have to leave that as is. So that is the dimension of each side. Now we could figure this out. If you plug this in the calculator, you get x equal to 4.49 inches. So the actual dimension is 4.49 inches times 4.49 inches. And so actually the approximate dimension. This is the more exact dimension, but if we want to know what that is in decimal form, it's 4.49.